Thank you for joining this lesson. Number 16, Mathematics Paper 1, Linear Inequalities. We try to find the inequalities that define the region R, shown in the figure below. So we can see region R here, bounded by two borderlines. Okay, three borderlines. We have L1, L2, and L3. So we can get the inequalities represented here. We start with L1's inequality. We can see L1 is along the y-axis, and y-axis is the line x equals to 0. So this inequality now is going to be inequality x, because the required side is the one with x greater than 0, and the borderline is a complete line, we say, or equal to 0. So this will be the first one. The second one is the line, the borderline L, whereby we're going to say for L2, we pick two coordinates along the line, and on that line we can choose to pick the intercepts, whereby we have the x-intercept as 5, 0, and y-intercept as 0, 4 for that specific borderline. Then we get to its gradient. So gradient of L2, we can call it M2, is going to be 4 minus 0 divided by 0 minus 5. So this is 4 divided by negative 5, which is going to be negative 4 out of 5. So now with the gradient, we can get into the equation, whereby we say negative 4 out of 5 equals to, we take a change in y out of a change in x by taking any of these coordinates and another point xy, another point xy. So y minus 4 and x minus 0 and x minus 0. So now we cross multiply. Y minus 0, it just becomes y. So we shall have this one as 5y, then this one is negative 4x, negative 4x. Remember, negative 4 by 0, or rather x minus 0. Just a minute. We should be having y minus 4 and x minus 0. Yeah, in that order. So negative 4x is okay after cross multiplication, but this one should be 4y, then negative 20. We should be having 5y minus 20, whereby we can have 5y equals to negative 4x. The 20 now becomes an addition. After the borderline equation, we can now decide the inequality to be used in this case. So we can pick a point on the required side, and we can choose a point like let's say a point here. So this point will be 2, 0. Let's choose coordinate 2, 0 for these inequalities. Where we have x now in our equation, we fix 2, and where we have y, we fix 0. So this side becomes 0 because y is 0, and x, which is 2, multiplies here to give us negative 8 plus 20. Negative 8 plus 20 gives us 12. So instead of the equal sign now, we compare the relationship between 0 and 12. The relationship is that 0 is less than 12. Again, we compare, is the borderline complete or dotted? It is dotted. So there is no or equal to. So now we rewrite this equation of the straight line as a borderline. 5y less than negative 4x plus 20. Then now we have a third borderline, and we can pick two coordinates along that borderline, whereby we have 0, negative 3, and we also have 4, 0. 4, 0. So now with those points, we can get gradient for the third borderline. 0 minus negative 3, it becomes positive 3. because it is 0 minus negative 3. Then 4 minus 0, it becomes 4. So the borderline has a gradient of 3/4. So we can now say 3/4 equals to, we let another point to be xy. So y minus 0, x minus 4. So this is going to give us 4y equals to 3x minus 12. So this is the equation of the borderline. Equation of the borderline, we use again a point on the required side, 2, 0. Where we have x, we put 2. Where we have y, 0. So this side becomes 0. And when we have 2 here, this side is going to have 3 by 2, which is 6, minus 12, which is negative 6. So 0 and negative 6, and 0 is greater than negative 6. And now that the borderline, the third borderline, is complete, then the equation will be written as 4y greater than and equal to, because of the nature of the borderline, it is complete, 3x minus 12.